In this presentation, we will compare the time complexities of adding the data at the beginning of the linked list and adding the data at the beginning of the array. So let's get started. Here we will first see the time complexity in case of adding the data at the beginning of the linked list and that to a single linked list. These are the two functions which are available in front of us. We have already seen these two functions. They are nothing but the two different versions of the same function, that is add_beg function. These two functions are helping us to add the data at the beginning of the linked list and that to a single linked list. We can clearly see the time complexity of these two functions will remain same, that is big O of 1. Because here we have these lines of codes and we have no loops or repetitions. That is why the time complexity will be big O of 1. Let's see what happens when we add data at the beginning of the array. Let us consider this example in order to understand how to add the data at the beginning of the array. Let's say we have this particular array and we have this data that we want to insert at the beginning of this array. For this purpose, we will move this data towards this array. But wait, here you can clearly see that already we have a data at the beginning of this array. We need an empty slot here so that we can add this data at the beginning of this array. For this purpose, we need an empty slot here. We will shift all the elements towards right, and then after that, we can clearly see we have an empty slot available with us so that we can easily add our data. Now, this much amount of work is required in case of array. If there are n number of elements in the array, then n shifts are required. This means that time complexity will be big O of n because we need to shift all those elements towards right. Inserting the data at the beginning of the array is not that easy. It requires some amount of work. That is why the time complexity in this case is big O of n. Let's consider this program which helps us to add the data at the beginning of the array. Here this piece of code is helping the user to enter the number of elements and enter the elements. Let's say user has entered the value of n as 4 and the values entered by the user are 1, 2, 3, 4. This n represents the number of elements entered by the user, that particular number. And the values entered by the user will get inserted in the array. You can see over here, this ARR is the array which consists of all these elements 1, 2, 3, 4 which are entered by the user. After this, we have this add_beg function which we will call for the purpose of adding the data at the beginning of the array. For this, we have to pass ARR, n and data. You can see over here the data consists of this value 10 that we want to insert at the beginning of this array. That's why we need to pass this data to the add_beg function. And here you can see this is add_beg function. In this add_beg function, we have a for loop. You should note this here that this is a for loop, right? Thus repetition is there because we need to shift the elements towards right. You can see here that I is initialized with n minus 1. We know that the value contained within n is 4. So this means that I contains this value 3. After this, we will check this condition is I greater than or equal to 0. Yes, of course, because 3 is greater than 0. We get inside this loop and here this I plus 1 will get replaced by 4 because I contains 3 and this I will get replaced by 3. This means that in index number 4, we are trying to add this data that is 4. So at this particular location, 4 will get stored. After this, we will decrement the value of 5, which means that this 3 will get replaced by 2. And after that, we will again check this condition. Again, this is satisfied, we'll get inside. And here in this case, this will get replaced by 3 and this by 2. So here in ARR3, that is at this particular location, we are trying to store this value that is 3. And then after that again, the I will get decremented. Now this time this will get replaced by 1. And then after that, we'll again check the condition. Again, it is satisfied, we'll get inside. This will get replaced by 2 and this by 1. So let me replace this. In ARR2, that is this location, we are trying to store this value that is 2. You can see slowly we are moving the elements towards right? After that again, we will decrement the value of I. Now this time this will get replaced by 0. We'll again check this condition. Again, this is satisfied because I is 0. 0 is equal to 0. We'll get inside this loop. Here we will replace this by 1 and this by 0. So this means at this particular location, we will store this value that is 1. We have successfully shifted all the elements towards right. Now this element can be easily replaced by our data. Here again, we will decrement the value of I. This time it becomes minus 1. At this time, the condition is not satisfied. Thus we'll get outside of this loop. This means we'll come at this line of code. That is ARR0 is equal to data. That means in the first location of this array, we will put our data. We know that data contain this value that is 10. So we'll replace this by 10. This means that our data has been added successfully. After this, we'll return n plus 1. That is the index number 5. So this is n plus 1, which means that it will get replaced by 5. So we are returning the index 5 back to the main function. This will received by this n. We will run this for loop then from I equal to 0 to n minus 1. This means that we will print all the elements of this array on the screen. Therefore, the output of this program is 10, 1, 2, 3, 4. This program is helping us to add the data at the beginning of the array. And of course, in this case, the time complexity will be big O of n. Because here you can see we have a for loop which runs from n minus 1 to 0, which means n times. And note that we are considering here that the array is not full. There is already an empty slot. Now let's see what happens when array is full. For this purpose, we need to copy the old array to the new array of size greater than the old array. Right? Of course, some new array has to be created whose size is greater than the size of the old array. This requires n amount of time because here we are copying the old array to the new array, right? So order of n will be the time complexity. And then after that, we can add the data at the beginning of the array, just like we have done before. So this will also take order of n time. So the total time will be n plus n, which is 2n. Again, this is order of n, as we can simply eliminate this 2 in the asymptotic notation. So the time complexity is big O of n in this case as well. Or you can do one more thing. You can simply copy the old array to the new array of size greater than the old array from index 1. Okay, so you will create a new array, and then after that, you will copy the old array elements to the new array starting from index 1, not from index 2. So this will take order of n time, right? And obviously, because you're starting from index 1, index 0 will be empty. Hence, you can add the data at the beginning of the array in constant amount of time. Just simply add the data. That's it. There is no need for shifts. Hence, the time complexity in this case is big O of n. Again, because here this is n plus 1. Although the time complexity is reduced in comparison to the previous one, but still asymptotically they are equal. So this is the overall time complexity when we are adding the data at the beginning of the array. We have considered the two different cases, that is when array is full and when array is not full. In both these cases, time complexity remains same, that is big O of n. So to summarize, in case of linked list, adding the data at the beginning will take constant amount of time, and adding the data at the beginning of the array takes order of n time. So linked list is better in this case. Okay friends, this is it for now. Thank you for watching this presentation.